Welcome, class, to the Intro to Java Programming. In this lesson, we will review the if, else, and else-if statement used in the decision-making process. In the previous lessons, we covered how expressions and operators are used to create conditions. These conditions are used in the decision-making process. Yes, let's do a simple example to illustrate the decision-making process. I need Virginia to think of a number from 1 to 10, and I need Han to try and guess that number. So, Clint, how will you know if Han guessed Virginia's number? Correct, if Han's number is equal to Virginia's number. And what will you do if both numbers are the same? The guess was correct. And what will you do if both numbers are not the same? The guess was wrong. Try again. You just created a decision and chose the action when the decision was true and false. A flowchart would look like this. Virginia selects a number, Han selects a number, a decision is made by evaluating a condition. Are both numbers the same? If true, the result is correct. If false, the result is try again. The if statement will perform the decision process. Here is the syntax for an if statement. We have the keyword if. In parentheses will be a condition that returns a true or false answer. The curly braces are used as a code block to hold all the code executed for the true condition. If specific code is needed only for the false condition, there is a command called else. Here's the syntax for the else statement. After the if block, there is a keyword else. The curly braces are used as a code block to hold all the code to be executed for the false condition of the if statement. The else statement is optional. In our previous example, we asked if Han's number was equal to Virginia's number. The true condition could return correct, the else or the false condition could return try again. Now imagine you wanted to respond to the number guess question with correct, higher, or lower. The if could still check if the numbers are equal. There is another else option called the else if. Here's the syntax for the else if statement. After the if block, there is a keyword called else if. In parentheses, there will be a condition that returns a true or false answer. The curly braces are used as a code block to hold all the code to be executed for the true condition of the else if. The else if is an optional statement. There can also be an optional else statement after the else if. Again, the else is optional, but if used, must be the last code block in the if statement. Inside the code block can be 0 to many lines of code. There will be a warning if you have 0 lines, so it is recommended to have at least 1 line of code. The code block for an if, else if, and else statement can contain another if statement. This is called a nested if statement. Here is the syntax for a simple nested if statement. Inside the code block for the first if statement is another if statement and code block. Yes, more and more if statements can be nested. However, this leads to Coach Joe rule number 25. Avoid nested if-else blocks. The term arrow code is used when there are multiple nested if statements. Notice this stripped down if statement. There's room for the tip of an arrow here. This is called arrow code. Junior level developers will write code like this. It is difficult to read, difficult to debug when things go wrong, and often has little or no unit test support. You should have few, if any, nested if statements. 0 is the goal. 1 in rare situations, never 2 or more. Good point. The number of else ifs used should also be few. You should never have 2 or more. Let's go to our basics project in IntelliJ. Close any open class tabs. Let's create a new test package called Decisions. Let's create a new class called ifTest. Let's make a little space, copy in this first test, import in these classes. This test will show an if statement with code for the true condition. An empty string variable is declared that holds the actual result. Here is an if statement with a condition, is 73 greater than 42? The condition is inside the parentheses. Curly braces to hold the code for the true condition. Inside the code block, we change the actual result string to bigger. And here we test to verify the result of actual result is equal to bigger. Let's run this test. And it passes. This test will show an if statement that will have a false condition and prove the code block for the true condition is not executed. An empty string variable is declared that holds the actual result. Here is an if statement and code block. 73 less than 42 is a false condition. This line of code should not be executed. Here we will test to prove the actual result variable is empty. If we run this test, it passes. This test will show an if and an else statement. Here is an if statement with a condition. Is 73 greater than 100? This is a false condition. Here is the code block for the true condition. Here is the else statement and the code block for the false condition. Here we will test to prove the actual result variable is smaller. Let's run this test. And it passes. This test will show an else if statement. Here is the if statement and code block. Here is the else if statement and code block. And the else statement and code block. 73 is not greater than 73, so the if statement will be false. The else if will see if 73 is equal to 73. This is a true condition, and this code block will be executed. The assert will verify that the actual result variable is set to equals. Let's run this test. And it passes. This test will use a logical operator in the condition. Here we set two variables. The if statement will check the result of two conditions separated by a logical operator to determine if the batter's turn is over or if he can keep batting. The assert will verify that the actual result variable is keep batting. If we run this test, it passes. This test will use the result of a method as the condition. Here is a private method that returns a Boolean result that determines if the batter's turn is over. The if statement will use the result of the private method as the conditional test. In this case, the batter's turn is not over and will keep batting. The assert will verify that the actual result variable is keep batting. If we run this test, it passes. In this final test, we create several nested if statements. Notice how the code forms an arrow. If we run this test, it passes. Here's a summary of all the code we wrote for this lesson. You should now have an understanding of the if, and else statements. You also learned about code blocks, nested ifs, and multiple else if statements. Although they are allowed, it is preferred to limit the use of nested if and else if statements. Your optional homework assignment is to create a test that proves an if statement executes code for a true condition. Write another test that proves that an if statement executes code for a false condition. In the next lesson, we will discuss ternary operators. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!